Okay, so we're going to start off with a bit of a reminder about domain and range. So we can ask what the domain and range of a function is. If we look at the graph, we can read these values off. We're allowed to write it in interval notation, but typically in IB we use inequality notation. So for the domain, we need to look at the x values along this line like this and see from smallest to largest what are the x values. So the smallest value for x is going to be 2. Now notice that the endpoint is filled in, which means it's an included endpoint. So the x values will go from 2, including 2, up to 6, not including 6. So 6 will be excluded. That's the domain. You can write it using interval notation if you wish as well. Sometimes it's much more compact. There's that.
There's a line at the middle of the thing when it's included.
That's just me showing you what I was about to do. So for the range, I'm going to try and describe these values here like this. I want to describe these values. So the smallest y value is not 25. Notice how we have to start the range off over here. The smallest y value is that one, which is going to be 10. This point is excluded. And then we go up to 25, and that point is included. Notice that this point is included. We can describe that using interval notation as 10 excluded up to 25 included. And this is how we describe the domain. Let's have a look at some different functions. Have a go for yourself now of writing down what the domain and range of this one is. You can have 1 minute. Okay, just jumping back to that one. This one for the range, obviously it should say y here. I wrote x to begin with, but we fixed it now. So let's have a look at the graph that we've got here. So for the x values, we want to start off here and we want to move in this direction. Notice that we have a continuous graph indicated by this little arrow heading off in that direction. So the range here is simply going to be x is greater than or equal to -2. Sorry, the domain. If we want to write this through interval notation, it would be 2 up to infinity. Our range is going to be similar, but it's going down. So the range value starts off here. What's that, 9? So we are going to have y is less than or equal to 9. We can write this as -infinity up to 9 included. Okay, let's have a look at the next one. Give you a minute for this one. Have a go for yourself. Okay, so for this one, our domain. So if we notice the domain on this one, it's going to be any possible x value. So we're continuing in a direction in both directions. So x is going to look like this. There's a few ways we can write that, but the best way of writing it is saying that x is an element of the set of real numbers with a double stroke r like that. So I'll write that in words. X is an element of, and then the r is the set of real numbers. I put a comma in, not because the sentence makes sense then, but that's where each of these symbols means. So x means x, the is an element of is that middle symbol, and then the set of real numbers is the double stroke r. So you draw 2 straight lines like that, and then an r like this, the set of real numbers. Y values are easier for our range. We've got a maximum at 0, 2. This is at 0, 2. So our range is going to be y is less than or equal to 2. Points on a curve are always included. Points on a curve are always included.
Can't you for the domain, can't you say negative infinity to infinity?
Yeah, it's less elegant. You don't get the style points. Some people really don't like intervals looking like that as well. State the domain and range of this function. Okay, so for the domain, it's not too difficult, this one. We're going to go from here to here. So we can write that as the domain is going to be -3 included up to 4 included, or -3 to 4. Our range, in this case, the range is going to go up to the maximum value there. It's a little trickier. So this is going to go from -2 up to this point, 3. So we are going from -2 up to and including 3. Don't always look to the end points when you're looking at the range. With the x values, it's typically just the end points, but with the y values, smallest to largest. Ooh, this one's a little bit trickier. So we need to state the domain and range of this function. Let's have a little look at it. What are the excluded values? I'll go straight into this one. We have some values here that are excluded.
X minus, y equals -3.
There are excluded values, excluded values. We can't have any x value here. This is x is equal to -4. So x equals -4 is an excluded value. So when we write the domain of this one, we have to include, I can't speak and spell at the same time. When we write the domain of this one, we have to say which values are excluded, and we can write it. I'm going to use set notation for this one, so I can say the set x is built such that x is not equal to -4, and otherwise x is an element of the set of real numbers. So a nice formal definition there. You'll get away with x is not equal to -4. Yeah, just the vertical asymptotes. So our range, now it works in a similar way. We have to see what the horizontal asymptotes are. What is the horizontal asymptote of this one? When you give an asymptote, always give it as an equation. So y equals -3. So our range is going to be, I can write it with set notation, y is so built as y is not equal to -3, where y is an element of the set of real numbers. Or simply, y is not -3. Can you do those type of intervals using interval notation? Well, yes, you can. Just add in a couple here. So if we want to try and do this one with interval notation, you would start at -infinity. You would go up to -4 and not include the point. Need the union symbol. And then we can go from there up to here. So you can do it with interval notation as well if you want. You'll get away with this. So why not? Okay. And don't forget the excluded values use an equal sign, so x equals -4. This is a discrete function. How does the domain of a discrete function look? So the domain of this one, we only have 4 values in the domain. So we start off at, the x is going to be anything such as -3, it can be -2, it can be 1, and it can be 2. That's the domain. There's only 4 possible values. There's no real numbers there. They're just integers. And the range would look similar. Just make sure we don't use the same number twice. You don't bother with use numbers twice, but there isn't any here. So we got -2, 0, 1, and 4. I'm going to skip over this one this afternoon. Are we good? All right. No, we're not good. Are we good?
Yes.
Okay. So we're going to use our calculator for this one. Dig out your calculator.
No, I put the brightness up on the screen.
Yes, later. Record. All right, so we are looking at the function and how to use the graphing calculator. So this is mostly about not necessarily the function notation, but the graphing calculator usage. We're going to pull up your graphing calculator. Start by pressing the on button here. Start by pressing the on button here. And we are going to want a new document. So new. Say no, this I don't want to save. Add a calculator. Then click the control button here on the left and click add page. And we're going to add a graph. This lets us add a function. We're going to just type the function in, x squared plus 1. Control add page. It's above document on the top right hand side. See, I'm pointing to it on the screen. Here. Okay, so then press control and move to the left. We're going to go over to here. Yeah, you do. It's exactly where I pointed to it. Maybe the person next to you can show you.
Control button.
Okay. Bring it here. So what we want to do is we want to evaluate the function when x equals 2. So for the first one, a, we need to find f of 2. And we just press variables, F1, type in 2, press enter, we get 5. I'll do it again. So we press variables, we typed it in F1, we type in 2, we press enter, 5. So for B, we're basically just doing the same thing again. We want to find f of -1. So in this one, we press the variables button here. Notice it's going red on the screen there. And we choose F1. We type in -1. So negative should be this symbol down here. -1. And then we press enter. And we get 2. Because you didn't put it in the graph. You missed a step. Okay, C. Now C is a little bit more complicated. I'm going to do this as a show that question. I'm going to do this as a show that question. I'm going to show you how to do a show that question. So we need to show that this point lies on the line. We need to show that f So we want to show that f of 5 equals 26. That means it would lie on the line. So to do that, we start at the left-hand side, which equals f of 5, which equals, and we're going to need 5 squared plus 1. Well, that is 26 plus 1, which equals, sorry, that's 25 plus 1, which equals 26. So that equals 26, which equals the right-hand side. Thus, we've created our first left-hand side, right-hand side style proof and made the proof. Okay. A function is defined as f of x is 2 minus 12 over x plus 5 for the domain minus 7 is less than or equal to x is equal to less than or equal to 7, and x is not equal to negative 5. So there it gives us the domain of the function. Most of the time when it gives a function, it does specify the domain for you. We're asked to find the range here. This is going to be a little tricky. So we are going to use our graph. Let's add a fresh graph. Control add page, add a graph. And we're going to start off by typing in our function. 2 minus, and we've got 12 over x plus 5. Our function looks a bit like this. Only it doesn't. Because what's important about this function is we're given this domain. We're given the domain here. That means we can't have all y values in this one. We have to stop at particular points. So those points that we need to stop at, we can get by tracing the graph. We choose menu 5.1, trace graph. We want to know what is the y value when x equals minus 7. So I'm going to type minus 7. Notice how it appears as x equals, a little data entry pops. Then I press enter here on the calculator twice, and it will put us in there. Now I'm going to type 7 and press enter twice, and we get the other point. Lastly, I'm going to press the escape button here at the top. See here at the top left corner, escape. When I press that, this is going to disappear. So it's stopped tracing now. We've got our 2 points. So I'm just going to extend the y-axis up a little bit. You'll see the shape of the graph. So our graph, I'll put this down a little bit, minus 20. Our graph looks like this. It's going to stop at these points. So if I want to sketch this graph, just draw some axes. Like this. Our graph is looking like that, and then like this. It stops at these points. So it stops here at 7,1. And it stops over here at minus 7,8. But it does continue down to negative infinity, and it does continue up to infinity here. So what is going to be the range of the function? Have a go at writing some inequalities to describe the range, or use interval notation if you wish. Discuss with the person next to you. I'll give you 1 minute for this one.
So for the trace, you press 5, and then
1. And then minus 7. Enter. Twice. Press enter twice. There. Then type 7.
type 7.
Enter twice. Then escape. Type 7. Press enter twice. Type -7. Press enter twice. Press escape. You done?
Wait, why is the intercept on
Because the domain is from -7 to 7. So we need to know what those endpoints are so we can create our sketch.
We don't include, oh, this is the domain. So would you only include the point that's like given on the graph here?
So everything from here up to there, and everything from there up to there.
Are you able to find the asymptote calculator?
No. Okay, let's have a look at our answer here.
I unsaved it.
Can I do the answer and then come? I'll help you in a minute. Let me give you. All right. So our graph. Ooh. I'm going to need to type an infinity.
I put the values, but
Sorry, I'm just looking for infinity. All right, let's have a look at our answer. So we need to go from negative infinity up to, well, the largest value is there on the right, up to 1. Then we're going to need the union symbol. Ooh, here it is. And that's going to go from, at the other side, we go from 8 up to infinity. Okay? And this is how we find the domain. The range, thank you.